Okay, recording started. This meeting, you see, it's almost 60 slides, so I'll try to go fast, not to go deep. So this is just me, many years, whatever, generative AI. So recent advancements in generative AI sparked interest, was increasing by more than 1,000% year over year, right? So here's some terminology. So generative AI, systems which enable users to quickly generate new content based on a variety of inputs, text, image, sounds, animation, 3D models, and other types. So ChatGPT is text to text. It generates, you give it prompt as text and it generates text. LLM, large language model. So it may be text to text, text to image, and so on. GPT, generative pre-trained transformer. For example, the ChatGPT, all the GPT models, they're generative pre-trained transformer. They are transformers. And transformers were first introduced by Google. I'll talk about all these models. So ChatGPT is a web app based on GPT model, and it was released in November last year. A foundation model is any kind of big model, which usually takes millions or hundreds of millions to create. And then people can use the foundation model as a brain to create some applications. So LLMs are foundation models, text to image, like Stable Diffusion. These are all examples of foundation models. Well, AGI, artificial general intelligence, just a generic term. Okay, so this is a rise of interest in ChatGPT. So you see here this fast rise of interest. This is ChatGPT. If we remove this, just this curve, so this is the rest. So, and it's still machine learning, deep learning, it was explosion, but ChatGPT is like explosion of explosions, right? So again, chat is a chatbot, it's a chat software, GPT, generative pre-trained transformer, LLM, large language model. As you know, ChatGPT is now used everywhere, and you can use it for writing posts, articles, books, summaries, planning, research, engineering, resolving problems like support, sales, and so on. Okay, what is generative AI? Well, I already told that this is a system, a model, which creates text, video, images, or some other content. Generative AI models learn the patterns and structure of the input training data, which is usually tens of millions or hundreds of millions of data, which may be sentences, paragraphs, tuples of text and images, whatever. And once they learn this data, then they can generate new data similar to what they learned or based on what they've learned. So in classical machine learning, we predict something. So for example, we have points and we draw the line so that given X, we can predict Y. Or classification, again, it's about describing the data. So let's say you have trained the model on pictures of cats, dogs, and other animals, and then you give the picture and the model can predict that this is a cat, right? Classification. Or there are many other types of models. But then generative AI, it's not about predicting, it's about creating new content. And the new content may be text, code, images, and so on. Does generative AI create new content? Well, it creates it, but it doesn't create it from nothing. It creates it based on a lot of data it has learned, and usually in tens and hundreds of millions of data points, or like data examples. So what kind of generative AI models we have today? Well, again, LLM, large language model, For example, OpenAI GPT, Google Bard, and so on. Bard is like Shakespeare, somebody who writes poetry and sings songs and so on. That's inspiration for the name Bard in Google Bard. And FM foundation models, all kind of complex models that can be foundation for specific models. So technologies which I will tell about these types of models is GAN, which is Generative Adversarial Network, GPT, which is Generative Pre-trained Transformer from Google, and VAE, Variational Autoencoder. And there are some examples, like DALL-E 2 from OpenAI, it creates images from text. Midjourney does the same thing, although under the hood they're a little bit different. ChatGPT, you know, generate text, answers questions, translations, and so on. And Bard from Google, kind of like ChatGPT. Several months ago it was very bad, now it's much better. And the benefit in comparison to ChatGPT is that Bard actually has access to the new data, most recent data. And yeah. Massive investments in generative AI, right? Well, first of all, creating a GPT model is very expensive. Like I read different estimates, but for OpenAI to create GPT models, including ChatGPT, is estimated about $500 million. So it's a huge investment, and they couldn't do it themselves. So they used Microsoft to build the data centers and infrastructure for them. According to PitchBook data, the generative AI market is predicted to reach 42 billion in this year, and in like 3 years from now, about 100 billion. So it's a very, very fast growth, big market, a lot of investments. Some big players, of course, OpenAI, ChatGPT, Google Bard, Baidu's Ernie Bot. Well, Baidu is like Chinese Google. So it's a very big company. Salesforce, CRM, Einstein. Well, Einstein is the analytics system. I don't like Salesforce, but they do have their own version of it. And Microsoft. Well, Microsoft and OpenAI is one and the same. And in Azure, you now have OpenAI interfaces, APIs, documentation, and you can run all kinds of models. And they also included the same models in Copilot, Bing, and even in Office 365 applications. And there are many other examples. Okay, I really like this video on YouTube, which features Mark Rusinovich, who is CTO of Azure, and he talks about infrastructure behind GPT models, which is huge, massive, all around the world, very expensive. When he talks, it's about 15 minutes video. You can understand the complexity and the scale of the project. It's absolutely amazing. So what's happening now? Investors started trying to repeat OpenAI ChatGPT success, right? So they're investing hundreds of millions of dollars to build new models, new infrastructures. Well, it makes sense, but it's also very risky, because when OpenAI was doing this, they were all by themselves. They didn't have much competition, and they invested. I mean, there was a very risky bet, right? They spent like $500 million, but now multiple companies get investors to spend like hundreds of millions of dollars to train some new models. And what will happen with this money? Well, they need to buy some hardware, they need to buy NVIDIA GPUs and so on. It's good for NVIDIA, but think about this business, because they spend this money, they build their data centers and servers, and they train the model. But in 2 years, the price of training will go down from 100 million to maybe 5 million. And so most of the money will be lost. So it actually probably makes more sense to invest this money into a building or a road or a bridge. It's less risky. But there is other thing which you can do with AI. You can use existing systems like GPT models and other models, and some models are open source, so they're free. And maybe they're not as advanced as GPT-4, the latest model, but they're much cheaper and maybe quite capable to solve specific problems for clients. And we can build apps and services for clients. Now, there are two approaches how you use the big foundation model. One is you take the model and you try to learn, to teach it some new tricks. This is called transfer learning. The problem with that is that, well, how you teach it? You use your data, and you don't have a lot of data, and you have huge model which was trained on, let's say, 40 terabytes of data. So it's very difficult to overpower this big model. Another approach is you don't overpower it, but you modulate input and output. So you put the model in the center, but when you receive a request, let's say from the client wants to ask a question, you, before sending it to the brain, to the large model, you change the request, you add something to the prompt. And this can be done in a very clever way, and this is actually called embeddings approach, which I'll talk about a little bit later. And it is much safer to do it this way, and it's also much cheaper than training a new model or overpowering the huge model. Now I want to spend some time talking about three main types of big models, which is transformer architecture, GAN, generative adversarial network, and diffusion, and stable diffusion. So first of all, you will see these models everywhere. And the example is DALL-E 2, which is a famous service from OpenAI, which is free, which allows you to generate images from text description. And DALL-E 2 uses all three types of models inside. And well, I will not go into the details. Let's just go talk about the models. So first, transformers. A transformer, it's an architecture designed at Google when they were doing Google Translate, and it transforms sentence or paragraph from one language to another. That's why it's called transformer. And here's kind of the history of development. It started from using a word dictionary, and then if-else models written by linguists, and then word-to-vec model where you incorporate not only the word, but word neighbors, which are words coming in the sentence before and after this word, and it's called word-to-vec. And then attention mechanism invented at Google at 2016, 2017, and there is a famous article, "Attention is All You Need," by Google people. So this is quite amazing. And let me see. So this is some demonstration. So this is word-to-vec. Word-to-vec is about 2013, and again, it's at Google. And what it does, it trains a simple network so that it can use vectors, and vector length may be about 100, so it will be 100 numbers. So each word end up presented by a vector, and similar words will have similar vectors, even if the spelling of the word is completely different. But as long as the meaning is similar, the vectors will be similar. And you can do vector operations between them. So, like, for example, this is man, woman, king, queen, and you can do some vector arithmetic with them. And this simple, very, very simple approach was in just few years substituted by attention mechanism, where again, words are represented by vectors, but instead of just using the nearest neighbors, it uses all words in the sentence or in a paragraph, and it builds a big matrix called the attention matrix, and it trained to calculate the coefficients in this matrix to make sure that it will not lose important words and important relationship between the words. And this is the diagram of transformer. It's really like you need like half an hour to explain how transformer works. But what's important is that there are two pieces: encoder, which encodes text into some internal vector representation, and then decoder, which converts this internal representation into the output text in a different language. And then there is a feedback between those two pieces, encoder and decoder, to make sure that important pieces, important relationships are not lost in translation. So it's very clever architecture, and now it's used everywhere. And BERT, it's a bidirectional encoder representations from transformer. What it is, it's just this piece of transformer. So it's a model which learns to encode something into a vector. Like in Word2Vec, we convert words into vectors, but then people created so many different models converting anything into vector, something into vector. And BERT is like the modern way to do it. The good thing about it is that it can be pre-trained, and it can training can be parallelized. So you can do it on distributed architectures, do it very fast and effectively. So you do pre-trained deep bidirectional representations from unlabeled text. Yeah, and this is BERT from Sesame Street. Okay, next type of model is GAN, Generative Adversarial Networks. And this is absolute genius. Oh, so Jan Goodfellow came up with this approach in his PhD thesis in Montreal in Canada, 2014. And I think it actually was 13, but 14 was a publication. But anyway, GAN consists of two pieces, two networks, which are trained together, helping to become better when they're actually competing with each other. So one, I'll call it a police detective. It recognizes images and it tells you if this image is true or fake. And the other is network, is creative, a generator. It's artistic, criminal. So let's say it creates a fake, and then it gives it to the police detective, and detective discriminator, it says, oh, it's a fake, or maybe it's real, right? And then this goes, the result of this, is it true or not, goes both to criminal and to police detective. So police detective learns to become better at his discriminative work, and criminal also learns, oh, this guy, the policeman, doesn't know how to figure out this image, so let me give you more images like that. So as they continue training, they become better and better. One at creating fakes and another at recognizing fake. After you trained it until it doesn't become any better, you can take this artistic generator and tell it, well, just keep generating images for me. So for example, there is a famous website which is called This Person Does Not Exist. You can Google it, and it just shows you images of people, high resolution. They very real. You can see like brows, every hair, like eyes, like really real. But these are synthetic images. These people actually don't exist. And you can provide like what age you want, what sex, what ethnicity, whatever, and it will generate multiple images of whatever you want. So this is example of a generative network. And again, this is 10 years ago. Today, there are versions of the same network which are much bigger and much faster. The latest is GigaGAN, and it can generate 512 by 512 image in 0.13 seconds. So it's quite amazing. Getting better. There are multiple versions of those GANs. Another way to generate images is stable diffusion. And stable diffusion is associated very firmly with the name Imad Mostak and his company Stability.ai in England, UK. And they produce open source. And it is does things similar to GANs, but completely differently under the hood. So what it does, it learns to generate images from textual description. And the way it does it, it first is trained on multiple pairs of text and image. So you have textual description of the image, or maybe some tags, and you have an image. And you have a lot of those tuples of pairs of text image. And you train the network to encode text into some vector representation and image into vector representation in a way that the vector from text and vector from image become very, very similar because they're actually part of the same tuple. So it's not just you encode it, but you encode it in a way that latent vector from text and latent vector from image are basically the same. And by the way, when they say vector, it's actually not a single like dimensional vector. It's a two-dimensional tensor. It's like 77 rows, 768 columns. This is like a typical size for a stable diffusion model. So once they learn to convert each text and each image into this vector, they train the model. Now, what you can do, you can take any of these vectors and convert it back to image, right? But now let's say you give it text which it never seen before. So it will use the text encoder to convert it to some two-dimensional tensor, and then from this tensor it will create an image. And if your text is a combination of several, it has features of several like text which were in training, so the output will be also a combination, and they want to do it gently, not to get stuck in local minima and whatever. So they use the variational autoencoder technique, which I will not go into right now. But the point is that they add noise and then they remove noise, and they get a low noise output, which somehow reflects the text. Input text is converted to output image. So it's a very interesting technology. Here I provide some links and some good descriptions of how it works. So again, generating images from text, you have Open DALL-E, DALL-E 2, you have Midjourney, and you have Stable Diffusion, you have GigaGAN. Okay, let's proceed further. Systems with brain in the middle, from hardwired rules to generic system. So classical machine learning trains a model which you can think of as a function or as a hardwired network. And once trained, it doesn't change, and for given input, it gives the same output. And this is kind of old classical approach. And what we're doing now, we're becoming the new systems. They're kind of like humans. They have brain in the middle, which is generic and which can solve multiple types of problems. Maybe not with the same precision, but still it's better and easier to train. And I want to make a parallel with how we created a device like 30-something years ago. This is me, this is Dima, and this is Nikitin, doctor. So this is our team. And the idea was, so we took a prototype which is a custom electronics medical device, right? So it has inputs, you see some wires here, inputs and outputs, and in the middle there are a lot of transistors and resistors and so on. So it's custom electronics hardware. And what we did in this device, we basically ripped out all this custom electronics, and instead we put a brain, a computer, so that instead of custom electronics, we can use custom software. Inputs, outputs, and in the middle, computer brain. Now, similar thing is happening in machine learning. So the classical machine learning models, you have data input, you have some action decision on the output, and in the middle, you have hardwired formula or network or some sort of algorithm. And we're shifting from that to the brain in the middle. So again, data on input, action decision on the output, but in the middle, we have this large language model. So we may convert data into text, feed it to LLM, and then it gives the output, and then we convert it into the output decision, right? So we need some sort of a wrapper around the brain. And that's what many people are doing now. Okay, ChatGPT plugins. Again, GPT in the middle approach. So, you know, for iPhone, we have App Store with 2 million applications. For Android, we have Google Play Store with 3 million applications. Now for ChatGPT, OpenAI created their own, like, I don't know, store or what they called. They started with 70 plugins, and it was about a month ago. So it started with 70 plugins. 2 weeks later, it was about 200. I just checked today, it's more than 400. So it's growing very fast because anybody can develop and post a plugin for other people to use. And these plugins allow ChatGPT to browse internet, read PDF documents, look at images, access third-party data, business systems, websites, provide services. So you can provide a human interface to many services now. So people can make requests using language, like English language, and this will be converted into whatever business API needed, run the request, and then return the result back to the user. So it's very powerful. There are a lot of those plugins available, and we definitely can use some of them. So these are some links. So what we're seeing now in machine learning AI area is a lot of transitions on how things are being done. So first we're going from tabular labeled data, like standard database spreadsheet type of data, to big unstructured data. From exact calculations to approximate calculations and similarity search. Vector databases. So this is from tabular SQL databases to vector databases, and from hardwired specific systems to generic brain in the middle systems. Okay, so current trend is replacing specific models with foundation models in the middle, and there may be text-to-text, text-to-embedding, multimodal. So embedding is this hidden vector representation or tensor representation of input data. So once embedding is a way of representing complex data in a low dimensional space that is more suitable for processing, typically as a vector or a matrix. So these are some examples of GPT models, different versions, text, conversation, code. So you give it a prompt and you get a response. In this case, it's a database query. Or, for example, you give it a prompt to create an image, and the response will be the image. It's generated based on the description. Tree of thought approach. This may be too much, but the idea is that large language models are trained on sequential data, and they cannot think in a structural way. So you have to add some sort of table of contents and like build a tree of logic using, let's say, ChatGPT or BARD to build the tree, but still you need to guide it into the direction of building the tree of thought. So this is just example of different providers. Like you can use OpenAI, Cohere, Hugging Face. Hugging Face, by the way, is in New York, and it's a company which provides a lot of pre-trained models which people can use. Okay, this is a little bit about sizes of GPT models. So you see that GPT-3 was trained on 45 terabytes of data, and the resulting thing needs about 70 gigabyte of memory. So we're talking about 50 times compression going from original data into the model which can be used. There is another big model, Llama, from Facebook. People say that it's primitive in comparison to ChatGPT, and there is a very big model by NVIDIA and Microsoft, which is even bigger than GPT. But anyway, so there are some recent developments. Google Bard. I start loving Bard more and more. I really recommend to start using it. It's free. AI in Google Workspace, it now works, so you can use it in Google Sheets or whatever. Microsoft, similar thing. You have Bing search engine, which understands questions like ChatGPT. You have Microsoft 365 Copilot, GitHub Copilot. Well, GitHub is owned by Microsoft. And NVIDIA has its own tools as well. So what ChatGPT can do today? Well, ChatGPT knows a lot of facts, and it's amazingly how it can understand your question. And if you don't phrase the question perfect first time, you can try again. And it's actually easier to do research with ChatGPT or Bing than it is by just running Google queries. But it's not always correct. It may hallucinate. It can invent things which don't exist. So you always need to check the facts. It usually gives you most common answer, which may be wrong, because there are many common misconceptions. So you have to be careful about things like that. May give you biased, politicized answers. Can help you with simple technical tasks, including software, writing, planning, and so on. But for more complex things, well, human is still needed. ChatGPT can easily be confused trying to solve real-life problems. It's still not a good substitute for a human. But it's getting better so fast. Like they made it to take the lawyer's exam. At first, it was like a low 10%. Then, after several months, it was in top 10% with ChatGPT 4. Now, recently, it passed the MIT entrance exam with flying colors. So it was common for people to complain that the models doesn't handle math very well. But now it's getting much better with that. So about approximate analysis, similarity search, and vector databases. So we go from data to some embedding vectors, latent representation inside the model, and finally to similarity search. So you find similar vectors. So people creating databases for that. This is a very active area. Multiple databases were created in just recent years. So there are some lists of those databases. These are their logos. And this is example how you use, in this case, it's Redis. This is one of the database providers. And let's say you're building a website for the clothing and you select a sneaker and you ask to show you similar sneakers, and you see it does it. And this is done using vector database, which does similarity search. So it's very interesting. Now, dangers of AI. What happened in March, lots of people signed a letter warning about dangers of AI. So this is actually the text of this letter. I will make this PowerPoint available to everybody, so you don't have to read it right now. And there was a lot of discussion, and I really like this video by Jan LeCun and Andrea NG, and they say, well, you probably should regulate what the model does in production, but you should not regulate research. You should let science be free and continue. Anyway, example of large language model usage. So for writing. So this is example how you create hierarchical table of contents and write a book using ChatGPT. Or you can use it to create software. I've done it multiple times. I absolutely love it. This is an example, like a good article, how I save many hours using ChatGPT as a data scientist. And these are operations which it helps with. So automate using GPT APIs. On Azure website and also on OpenAI, there's a documentation how to use the APIs, and you can have a Python script which makes queries to the model, and you can automate things. And okay, use ChatGPT as a private teacher. I use it all the time. Ask GPT for advice about life and health. Scan and describe images with ChatGPT. Summarize articles, papers, and posts. So these are just examples of what it can do. So this is example how you call API using Python or using CLI, command line interface. So just from command prompt, you can do curl, go to this API, OpenAI website and give it some parameters. And here you see it provides what is the joke of the day, and it will answer you with the text with the joke, right? This is LangChain, and it's a framework developed to use those APIs and to build your own applications. So it's big, they received a lot of money, it's a fast-growing company, and we can use something like that to build our own application. Chat PDF, well, if you need to read PDF and summarize it and answer questions about it, so it's both how you're reading, parsing, and also using a large language model to answer questions about it. Okay, modern foundation models moved into clouds because they're big, they're expensive, and they exist in all clouds. So, and this is different because classical machine learning, you would run models on your laptop, but nowadays with this brain in the middle, the brain should be in the cloud. And this is a big change. Like in 10 years ago, IBM Watson, it was a mainframe, right? But nowadays, everything is in the cloud. And you can see examples at Google. So you can see text, code, image, embeddings, audio, music, chat, dialogue. And let's say, and this is Azure, OpenAI. And again, content generation, summarization, code generation, semantic search. These are all similar, and the underlying models are very similar. If you just go and Google for how to make money with ChatGPT, I didn't even like describe because there are so many things people do to make money. A little bit of philosophy. So AI models are getting better and faster and faster because what's happening now, you can ask AI to design better AI, new AI architectures, train them, improve them, select the best by competing against each other. That's what DeepMind does when indeed when they were training AlphaGo and other games. This is what Tesla is doing when they're training their self-driving algorithms. And now the question is, in order for these algorithms to be effective, you have to give it more freedom. So do we need to go as far as God and give like free will? Like this is something people discuss, right? I was really blown away by what Sam Altman said. So Sam Altman is OpenAI CEO and co-founder. So he's probably the most important person on the planet right now, right? And these are some of his quotations. I grew up implicitly thinking that intelligence was like a really special human thing and kind of somewhat magical. And now I think that it's sort of a fundamental property of matter. That when the system becomes complex enough, intelligence may appear, and it doesn't have to be, the structure in the system doesn't have to be very complex. It's just that the system needs to be big enough. The history of scientific discovery is that humans are less and less at the center. We used to think that sun rotates around us and that we're center of the galaxy. Even if like humans aren't special in terms of intelligence, we're incredibly important, we're on an exponential curve. Truly, we have an algorithm that can genuinely and truly learn, and it gets predictably better with scale. The rate of progress in coming years will be significant. Well, we see it's happening right now. Okay, Andrew Ng is a Stanford professor, creator of Coursera with the courses, and they have multiple trainings which they now offer for free. Well, I didn't check today if they start charging for them, but they talk about using ChatGPT API, prompt engineering, LangChain, which I mentioned, this is the framework to do applications, and the diffusion models, which I mentioned before. So you can, if you like Coursera, I highly recommend. They usually have very good courses. Now, if you look at how people use generative AI today, so they use it for different purposes, like, for example, automation, decision-making systems and workflow optimization, like Tesla self-driving, Salesforce CRM workflows, creating new content, whatever it is, personalization of communication, generative design, creating tools that generate designs, models, prototypes, and so on, and platforms and solutions, building platforms, interfaces, and solutions for other businesses can use to create their own applications and products. This is usually heavy lifting, and this is probably not exactly what we want to do, because I don't think we have enough resources to seriously go after something like that. Here, I don't know. Okay, this is example of like more detailed list of different things can be done. Like for example, for 2D media, avatars, content, like whatever. This is the table, and this is the list for like short, and also for 3D media, for code, for vertical applications, and there is not even mentioned things like videos and oh no, it's here, video generation and editing. Yes. Okay. There are two more slides. So one is examples of AI-based applications and services which a regular business can use. It may be profit or non-profit, and there may be more, but this is something I like ordered in the order of, I think, like how generic they are. Like for example, translating into different languages. So each business has maybe a website or some documents and whatever, and you can use AI translation. Now it becomes very good quality, and you can easily translate, let's say, your website into 100 languages. In fact, for nonprofits, you can use this service, which is called Google Translate Website Translator, and it's free for nonprofits. They need to just apply and get it, and boom, website is translated. And what it makes for the business, that people from other countries can suddenly read the website and then decide, let's say, to make a donation. So you can expect 10-20% increase in business or in donations by doing something very inexpensive, very straightforward, like translating the website. But you can also translate a lot of literature, manuals, emails, posts, communication, customer service, and so on. Generating content. This is again what large language models like ChatGPT is famous for, and can be used for a variety of purposes: blog posts, social media posts, videos, educational materials, infographics, and so on, so on. Communicating with clients in a clear and concise way, right? To build trust and rapport. Personalizing communications with clients, donors, using email, direct mail, may increase responsiveness because what AI can do, it can use the previous history of communicating with this particular client and like talk personally to this client. Answering questions, automating tasks, predicting future revenue donations, identifying trends, researching topics, generating reports, staying up to date on regulations. So you see, a lot of things can be done. Like my daughter's company, Vareto, they help with analytics. So they generate different kinds of reports, and they now edit AI to this. So basically, all they're doing is this. And it's just one of the things that can be done. So these are examples, and these are specific examples with nonprofits, how different nonprofits use these services successfully. You see, this resulted in 20% increase of donations and 1 million in donations, whatever. Very good results by using approaches which are very straightforward, easy to understand. Okay, I'm finished with the presentation. I will stop the recording.